Electron affinity is another trend that we can look at on the periodic table. I really like to understand where terms come from personally, so I look at the word affinity. And I know, generally speaking, affinity is having a desire for something, right? I personally have an affinity for chocolate. Some people may have an affinity for shoes, right? Having an affinity is having the desire to gain something. So if we have an electron affinity, we have a desire to gain electrons, right? So I also then tie that with what I'm willing to do to get what I really have my affinity for. And that usually means that I'm willing to give up a lot to get what I really strongly desire. So let's see how that plays out with electrons. So electron affinity is defined as the energy change that occurs when an electron is acquired by a neutral atom. So in this case, we are looking at forming anions because we have atoms that are gaining electrons, right? So how much energy is going to be involved in gaining an electron? That's what electron affinity is. Electron affinities are always negative numbers because what they are representing is how much energy the atom gives up as they gain an electron. Generally speaking, that's because it's becoming more stable, right? It goes from a higher amount of energy to a lower amount of energy, making it more stable. And when something is given off, it's recorded as a negative value. So if I really strongly had an affinity for shoes, that may mean I'm willing to give off a lot of money to get those shoes. What would happen to my bank account is I would be subtracting money from my bank account, just like atoms are subtracting energy from their energy total. So negative values make sense when you use that analogy, I think. So how much are they willing to give up in order to gain an electron? So our trend going across a period, well, if you think about as we move across the period, we start with the alkali metals. All of them want to lose an electron, right? Alkaline earth metals want to lose 2 electrons. The boron group 13 want to lose 3. Carbon's group probably wants to lose 4. Nitrogen wants to gain 3 electrons. Oxygen wants to gain 2, fluorine wants to gain 1. The ones that are closest to having the stable electron configuration by adding electrons are also the ones most willing to give up something to get them. So we find that the farther we get to the right, that they are willing to give off more energy in order to gain that 1 or 2 electrons. So the trend across the table is for them to have a more negative electron affinity. Going down a group, we see that they are actually going to have smaller negative values. They are less willing to give something up, which makes sense because they also are having probably a little bit harder time hanging on to what they have. I always think of it this way. If I'm having a hard time hanging on to what I have, why would I want to gain anything at all, right? If I can't carry all of my laundry, I'm probably not going to bend down and pick up that random sock that's laying there, right? So our trends look like this. Electron affinities are increasing as we go from left to right across the table. So higher negative values. It's always kind of weird to think of negative values as being higher, but more and more negative represents an increase in electron affinity. And as we move down a group, we will see actually that they are less willing to give up energy as we move down because they're having a harder time hanging on to their electrons. So the electron affinity is decreasing. The numbers would be getting smaller and smaller negatives. Our general trend is then up and to the right. So once again, pointing towards fluorine, right? Fluorine most benefits from gaining 1 more electron. because it also is the smallest and pulls the tightest on its electrons. It's also the one that's going to gain the most by getting that electron, so it gives off a lot of energy in the process. So that's our general trend then in electron affinity.